Everyone, it's Rahul. Today we are going to discuss how to debug a pod in Kubernetes. In this video, we will discuss what are the various common issues for pod in Kubernetes cluster and how to debug them effectively. The various common issues for pod just like as CrashLoopBackOff, ImagePullBackOff, insufficient resources, probe failures, either it would be Liveness probe failure or Readiness probe failure, or no disk crunch issues or insufficient resources issues. So we will discuss all of these issues and how to debug them effectively in our Kubernetes cluster in detail. Now let's proceed and discuss each of them in detail, and we will do hands-on lab as well for debugging purpose. As we can see here, the first is CrashLoopBackOff. So what does it mean? I have already attached a snap as well. Whenever you try to see the kubectl get pods, if your pod is in CrashLoopBackOff state, you can see the same snap. The status would be shown as CrashLoopBackOff and the restart count, that is 5, and what will be the age of that particular pod. It will show here, and as we know that the pod is already in CrashLoopBackOff status, that's why pod count is showing as 0 and required is 1. So what does it mean CrashLoopBackOff? It means that when pod is failed to start repeatedly, this is often due to the application misconfiguration or runtime error. The application is running in containerized form in your pod. If there would be any application misconfiguration or any container runtime error occurred for your pod, so this type of error you will face in your Kubernetes cluster. So we will see these things in detail in our lab and we will see how to debug it. Now let's discuss ImagePullBackOff. So this error occurs when your Kubernetes tried to pull the required image from the artifact repository. Either it would be the Docker Hub, Nexus, or any other repository. You can see here this error occurs when the Kubernetes cannot pull the specified container image, usually due to incorrect image name or a lack of access. So it means that whenever you are trying to container application in pod, you need to specify the image name of your containerized application and where you have stored your image. Either it would be the Docker Hub or any other artifact repository like as Nexus, that kind of thing. You need to pass the credentials, or you can say that how your Kubernetes cluster will make an authentication with your artifact repository. So if there would be any lack of access doing so, or there would be any incorrect image name, then you will supposed to receive such kind of an error, that is ImagePullBackOff. As you can see here, the ready status which was showing earlier in CrashLoopBackOff, here also it's showing 0 by 1. So pod itself is not ready, that's why it's showing 0 by 1 and the status is showing as ImagePullBackOff. Now let's proceed and see our next issues. This type of issue occurs when your node is not able to fulfill the requirement for your pod in terms of resources. So this type of issue occurs when your node is not able to fulfill the requirement of your pod or your applications in terms of resources. So it's mentioned over there, pod might not start if there are not enough resources, either it would be CPU or memory available on the nodes. So as you can see here, the status in that case for insufficient resources would be pending, and the same, the ready would be 0 by 1 because the pod is not started yet, that's why it's showing 0 by 1. We need to describe the pod and we'll try to see exactly which resources is crunched, just like as limit memory, request memory, or limit CPU or request CPU. Now let's discuss the fourth one, that is the network issues, or we can say that DNS resolution. As we know, in Kubernetes, pod is able to communicate each other in the same cluster with the help of cluster IP. Comes under the network issues. So in network issues can prevent pod from communicating with each other or external services. For debugging such type of network issues, what we have to do, we need to go inside the pod with the help of kubectl, and we need to do NS lookup, or we can do a curl to the internal API or an external API, and then we'll try to see exactly what's the issue and what's the error is. Now let's proceed to our next issues for pod. Next issues in pod of Kubernetes, that is readiness probe failure. So a readiness probe failures means the pod is not ready to receive the traffic. Let's suppose you have containerized your application in pod and you have set up readiness probe inside the pod application or pod manifest file. Your readiness probe is failing. It means that your application is not ready to serve the traffic. So in that case, the status would be showing as running, but when you describe the pod, you will get to know that readiness probe is failing and the pod count would be shown as 0 by 1. Now let's discuss the Liveness probe failure. A Liveness probe failures means the pod will restart it by the Kubernetes. It means, so if Kubernetes find that if not getting the expected output which you have mentioned over there in manifest file, so Kubernetes will try to restart the pod, or pod would go into the CrashLoopBackOff states until unless the required expected output would received from your application to the Kubernetes. So these are the mainly 6 common issues which we encountered in day-to-day activities for Kubernetes. So now let's discuss all of them in detail in our labs. Now let's proceed and do some hands-on lab. So as you can see here, I'm already logged in my Kubernetes cluster. I have set up this Kubernetes cluster from scratch on my GCP virtual machine. If you also wanted to follow the same and create your own Kubernetes cluster on your virtual machine, I will paste that video link in this description of this video. So as you can see, the status of kget pods, one of backoff, one of them having ImagePullBackOff, one of them having CrashLoopBackOff, and another one is out of memory. Now let's try to fix all of them and we'll see how to debug for such issues for pod in Kubernetes cluster. Now let's try to debug all of them. So what we have to do first, now we will discuss each one of them in detail. Let's first discuss the CrashLoopBackOff one. So what we have to do, k describe and pod, and what is the name of pod? So just copy the name of pod. Okay, after copying, paste it here. As you can see here, it's showing back of restarting the failed container and it is in CrashLoopBackOff state. So to diagnose or to debug it, to look for the main container status and what would be the exit code for that our main container. So just go on to the main container. As you can see here, the exit code is showing as 0 and the reason for that is completed. It means that there is no task has been mentioned or the argument has been passed for this container in pod so that it would try to run. The container goes into the completed state. After that, it is going on a CrashLoopBackOff state. So what kget pods, and we have already seen the kget pod status. This is the ImagePullBackOff. So now let's try to describe the pod, k describe pod. So as we know that in ImagePullBackOff, it would be either authentication failure or the image name would be the wrong. So k describe pod, just copy this, paste it here. As you can see here, it's showing that failed to pull the image TechWiseRahul. So I have intentionally mentioned the image name wrong. So we are going to edit it. K image, sorry, let me try to see. I have already created some YAML in my local. It's showing k get pods, sorry. So as we have seen that the image name was wrong. So to fix that, what we have to do, k edit and the pod, and we need to mention the pod name. Now we are in editing mode. We need to change the image name. So I'm just changing the image name from TechWiseRahul to Nginx. Just edit it, k get pods. Now you can see here image pull fail pod, the container or the pod which was earlier is in different state, now it is in running. So this is the way how to debug a pod for such issues. Now let's try to fix this out of memory issues. So k describe pod and the resource limit pod. What we have to now, after describing the pod, as we can see here, it's showing that node did not have enough resources. So there is an issue in the resources for this particular pod. So it seems that which is mentioned there in the resource section of the manifest of this pod is not or adequate to fulfill the requirement. So what we have to do now, we will describe it. K get pods, k edit and the pod name. Now go into the editing mode. As we can see here, limits we have defined the limit memory and the request memory. It's showing as 1000 GI. Now let's change it to 11 GI or in MI, because we are running on a simple busybox image. Annotations should be correct, otherwise again it would fail. Okay, our changes has been saved in this manifest file. What we are going to do, k delete the pod which is currently running, k resources limit pod, and now we are going to apply the manifest which we have just changes. We are going to apply the manifest where our recent changes has been saved locally. So just copy this manifest location, and as we can see here, the pod has been created. Now the resource limit pod, which was earlier showing as out of memory status, now it's showing as running. So we have fixed the image pull back off and out of memory, or in terms of debugging the pod, we have fixed image pull back off and out of memory issues. Now let's try to see the other pod, why they were failing. So k describe pod. Now try to see this readiness probe failure, why it's failing. As you can see here, readiness probe is failing. HTTP probe warning unhealthy, failed with status code 404. So what we have to do now, we are trying to see the logs for this particular application or pod. We can say that k logs, and here, so it's showing the status, our application is ready to serve the traffic or not. There is readiness probe has been configured. This is being configured with this URL /non-existent. As you can see in the logs of the pod, it's showing that no such file or directory for this one. So now we are going to debug it. So k get pods. Now we are going to edit this pod, k edit. I have already manifest stored for this particular pod locally. So I just open the manifest file for our readiness probe failure container. It was earlier showing as non-existent here. I have just removed it. Now let's try to save it and try to apply the same. Manifest has been applied. K create -f and ready.yaml. It will create a pod with the help of that manifest where the changes has been done after removing the non-existent from the HTTP GET. So for the readiness probe, as you can see here, now the readiness probe has been fixed, and now let's try to see the logs for that particular pod. K logs, copy the pod name, paste it here. As you can see, now we are getting the response. See, now we have fixed the image pull back off error, out of memory error, and the readiness probe failure. Now let's try to fix the remaining two, that is CrashLoopBackOff and the Liveness probe failure. Let's try to fix the Liveness probe failure. So k describe. Now first we will describe the pod. Whenever you are debugging the pod, first step would be describing the pod. After describing the pod, you will get to know why your container would be in exited state, or what was the reason for the last restart. After you know the reason, you can see the logs of that particular container or the main container which is getting into the CrashLoopBackOff or in a different state other than running. K describe pod, and now copy the pod name, paste it here. As you can see here, it's showing backoff restarting the failed container, Liveness probe failed. So Liveness probe is failing, can't open /tmp/healthy, no such file or directory. Now we'll see here where it is checking the Liveness probe. It's showing exe cat /tmp/healthy. So it's going to see cat this file in the delay for 5 seconds. Let's see what container is doing. So container is creating /temp/healthy and it's going in sleep for 30 seconds, and again it's deleting and wait for 600 seconds. For fixing this Liveness probe, what we can do, we can either increase the initial delay second, or what we can do, we can remove this operation which is being running or performed by this main container to removing the directory where Liveness probe is going to be checked. So what we are going to do, just remove this. It's up to you. You can, because we are doing this for the testing purpose, that's why I'm removing it. Okay, so I just removed it. Okay, just make them in quotes, sleep 30, Okay, our changes has been saved to this manifest. What we have to do, as we have done earlier, we are going to delete the existing pod and we will try to create the pod with the help of this manifest where changes has been saved. K delete, and this is the okay. As you can see here, now it's 10 minutes has been already passed and our container is in running status. So Liveness probe, copy this pod name, delete the pod, or forcefully what command we have to run, what we have to do, k delete pod and the name of pod hyphen force you can pass, or to delete it instantly grace period is equal to 0 we need to pass. Okay, it's going, as you can see here, it's already deleted, that's why it's showing pod itself name is not found. So k create -f, and this is the manifest where our changes has been saved locally. So I just pass that manifest location in this command k get pods. Now we'll see. So as we can see here, we have removed that particular argument from our main container where it going to delete that particular file /stamp/healthy where liveness probe has been configured. So now we have already discussed most of the scenarios for the debugging of pod and the issues. Only one is remaining, that is CrashLoopBackOff. Now let's discuss that as well. I've already seen the, now let's describe the pod which is in CrashLoopBackOff status. So after describing, we'll try to figure it out that why the pod is in CrashLoopBackOff state. So to check this, we have to go to the main container, and after going into the main container, we need to check the state section, and we need to check the reason why our pod went to the CrashLoopBackOff state. As you can see here, the region is showing as an error and exit code is showing as 2. It seems that there would be some issues while passing an argument for this container. Okay, now let's try to see that. K get pods, so k edit pod. We're going to editing this particular pod manifest. Now I just went into the editing mode. So as you can see here, going to do, as we have seen that there was an issue in argument. So first delete this pod, k delete pod, and we are going to create the same pod with the help of imperative, that is k run and the name of pod and image, that would be busybox. And what we have to do, we are going to pass the argument in our imperative command itself, that is --sleep is equal to 1000. So as you can see here, our pod would going to be created, our pod is going to be created and now it's in running state. So now our pod has been created and our pod is in running state. As we have already discussed most of the common scenarios for debugging a pod in Kubernetes clusters. Thank you for watching till the last. If you encountered any issues during debugging a pod in your Kubernetes cluster at your end, please feel free to comment on this video, so we will try to solve those issues. Thank you for watching. See you in next video.
Thank you for watching. Please like, share and subscribe.